Hi, welcome to Deep Learning ICP 6 in Python. This ICP is about how to analyze the simple and stacked autoencoders. The softwares that I have used is Python 3, Pandas, Keras, TensorFlow, and Jupyter Notebook. So the first task is adding one more layer to the hidden layer to the autoencoder. So for this, the first job is this is the given code where we have a encoded layer with activation with encoding dimension given 32 and the input image of the shape 784 and the activation layer for the encoding layer is ReLU and for another decoded layer is added where it's a dense layer with activation type of sigmoid and neurons 784. So actually here the decoded layer is placed just after the encoded layer, and to the autoencoder we are giving the inputs of the we are trying to develop a model with the input image and the decoded layer, and then the autoencoded model is compiled with the optimized at ADA delta and loss as binary cross entropy and matrix, and then we are training the data after normalizing it and then after reshaping it, and then we are fitting the train and the test data to the autoencoder with the epoch size 5 and batch size as 256. This is the structure that is given to this. Now in the first question, uh, I'm adding one more hidden layer over here. That is, this is the hidden layer that is added. This is added after the encoded layer. This hidden layer has the neurons as pytrol and activation as ReLU. Now this after this hidden layer, decoded layer is taken. So besides the decoding layer, we are adding the hidden layer over here. Now Uh, now another a new autoencoder add is the new autoencoder model that I am creating this is a model with input as the input image and the decoded, and now I'm compiling this model with the optimizer as ADA delta and losses binary cross entropy. uh, so after doing this again I'm normalizing it, and now I'm fitting this model with epoch size 5 and batch size is 256, and then we are compiling it. So after doing this, this is the first question, this is the end of the first question part, and coming to the second question, the second question is about doing the prediction on the test data and then visualizing one of the reconstructed version of the test data and then comparing the same test data using the matplotlib. Now, so coming for this one, first we are going to predict the data. In the xtext, we are predicting the sixth one. So to the autoencoder add, we are just predicting the sixth data over here. So coming to the prediction of it, first job is like this is the input image. The image that we are seeing is the input image, and the input image is taken as the sixth image from the test data. So the same image is visualized with the help of the matplotlib, and the second one is like we are trying to visualize the reconstructed image using the prediction data. So the prediction with the help of here the input image will be taken from xtext as well as the prediction image. Here we are trying to reconstruct it using the help of prediction. So this is the end of the question 2. So just coming to the question 3 here, we are repeating the question 2. Question 2 with the help of the denoising autoencoder. So here what we are doing is like we are introducing noise into the with the noise factor 0.5 into the autoencoder into the external interest. So after introducing some noise factor into the external interest, the new external interest will be extra noise and extra noisy. Now I'm just fitting this data into the autoencoder and then creating a history object over here. Here the epochs are set as 10 and then the batch size is 256. So after doing this again I'm just predicting uh, so here we are just creating new prediction object with the autoencoder.predict. We are taking some we are taking the excess noise instead of excess over here. So after that we are trying to visualize the input image. Here the input image will be the image taken from xtext, and then after doing this we are just applying noise over here. We are just trying to apply the xtext noise over here to get the noise image, and then after that doing that we are just trying to reconstruct the image with the help of the prediction data that we have created earlier. So after doing this this is the end of the third question. Now coming to the fourth question. The fourth question is about plotting the loss and accuracy using the history object. Here we are just plotting the accuracy and the loss um, over here with the help of the history object. And now the bonus is about visualizing the compressed version of the input data in the middle layer. Here also uh, we are creating an encoder layer and decoder layer, and then trying to fit a model and then just compiling the model that is created over here and then normalizing it, and and we are here trying to predict the encoded images with the help of the XTest data that is created, and then finally the images are visualized in the over here. These are the set of the images that are visualized after the compressed version. After the input data is compressed in the middle layer, and this is the end of the recipe.